Hi guys, welcome to my channel. Thank you for the views and comments that you had shared on my previous two videos. It really motivates me to create more content like this. So today we are going to drift away from what we were doing in the previous two videos. Instead of solving some SQL questions that I tried doing on my previous videos, I'm going to try to solve a machine learning question. So for this problem, I have sort of taken the data set from Kaggle. It's a fairly small data set. It has around 1400 rows and around 6 to 7 columns. Choosing a small data set gives me the room to explain topics more extensively. So in for my future videos, I'll try to incorporate large data sets. We'll try to solve some interesting machine learning problems on large data sets as well. So let us just jump right into the problem that we have here. So what we are trying to do here is, let's have a look at the problem here first. So you can see here, I have sort of loaded my data set into VS Code, where I have all my project files in one folder. I think this is a good industry practice. Also, like, I have loaded my packages into a virtual environment that allows me to have all the packages specific to this project at one place. Even if, suppose if I'm sharing this file or putting it on my GitHub, it allows my stakeholders to see all the packages at one place. So if you want a tutorial on how to set things up on VS Code, let me know in the comment section below. So first, as you can see, I have just loaded my data set here. So yeah, first things first, before jumping in or solving any machine learning or any analytical problem, it's always good to have a better look at the data set first. Instead of doing any manipulation, oh, maybe I should use this encoding for this feature, I should apply this algorithm. First thing that you have to look at is the data itself. What is your data telling you? So that sort of getting inferences at the beginning stage, or before starting a data analysis problem, gives a very good insight of how you're going to solve the problem. So what do I mean by looking at the data? So by looking at the data, I mean, let's just check, are there any missing values in the data? Like, how are the numerical features in my data set? Or maybe checking how are exploring what are the categorical features in my data set. What are the relation? Is there any relationship between my features? So like this sort of getting this understanding right in the beginning stages of your problem gives you a very sets the stage up to solve your machine learning problems in a more streamlined manner. So this is what we are going to do here first. So we're going to first just check my statistics of the dataset by using a simple describe command from Pandas. So let's see. So you can see for my first feature, which is age. So let's see what do we have for age. We can see like the minimum age is 18, the maximum is 64. So this sort of gives us a hint that it is a representation of the adult age proportion of what we have. So then we look at BMI. Mean BMI is around 30. We'll probably check this later because I don't know much what the mean BMI is in, or what range is it in. Let's look at the children feature here, what we have. So the mean people that in this data set have one child, but like 75% of the people in this data set have a maximum of two children. Like some people have five children. I believe these are some outliers. So yeah, majority of the data set has two or less children. So the charges, this is like the our main target feature that we are trying to predict. So you can see the mean charges is around 13,270, and the maximum is 63,770. So this gives us a good hint that the distribution of charges is heavily skewed. It's not like a perfect normal distribution, because it makes sense, because for most people they will be probably requiring basic medical insurance. Only in cases of emergency is when your insurance goes up. So yeah, this is what I was meaning by sort of delving deep into the data set first before just jumping on to doing algorithms and applying fancy metrics. So yeah, let's just look at another. Like, I just want to check what all, because describe doesn't give you much clarity about the categorical features. So I just want to explore what my categorical features are. So just let's look at the feature which is smoker. Let's see what are the values in it. Yeah. So for smoker, you can see it has mostly values like yes, no, yes, no. So yeah, we can do probably the same for what is my region. Let's see what are the values in region. So region also has four values: southwest, southeast. So what we are trying to do is, like, we had a look at categorical features now, and one more thing we can do here probably is, let's just check if there are any values in our data set. So for that, there's a is null command that Pandas provides, and we're just going to see if there are any null values in the data set. It returns uh, like, it'll tell you how the null value distribution is for each feature. So as we can see, there are no null values in our feature, which is fairly good. But remember, like, when you work in a real world project, like, you are bound to get some values, because when you're taking data from people, there will be some people who don't fill up the survey. So get access to null values is fairly common whenever you're dealing with an industry level machine learning project. So yeah, so now I want to sort of delve deeper into my categorical features first. Like, for that, we'll use like some visualizations to see how are they distributed across this data. So let's just check. There's this one function on in that there in the Seaborn library. It's called count plot. So let's just try. I'll just tell you, like, you'll get more clarity after I code this up and show you what it looks like. So I'll put my x equal to sex here for the first. I want to just see what is the gender distribution for my data set, and my data equal to data set. And I just want to, like, put a title for this. We'll use plt dot title, and we'll name it as gender distribution. And then we'll do plt dot show. So I believe, like, I'm getting some error with PLT, because, oh, I think I haven't imported the matplotlib. So no problem. We'll just install matplotlib to my virtual environment. Yes, and then I'll probably do an import matplotlib dot pyplot as PLT. So yeah, I think now this thing should work. So yeah, you can see, like, the overall gender distribution what we have here. So for that, like, maybe, like, whenever you run into any issues, you can just sort of, look up in like just you can check what your features are in like, you can just check up the internet for checking what your features are. So for here, like, we are checking SNS, like, count plot in Seaborn, right? So we will do count plot Seaborn and just see how does it work. So what the documentation says is, a count plot can be thought of as a histogram across a categorical feature. So yeah, whenever you want to explore more about categorical features, like, get their distribution, like, it's equivalent for a histogram what you have for numerical features. So yeah, like, if you just go on, you can just see, like, how it is implemented here in the examples. This is what I would normally do. So yeah, this is whenever you are running into any problem with any library, you can just Google it up. And yeah, let's just get back. So we understood that count plot is mostly used for our categorical features. So now, after doing on gender, I would probably like to visualize how my smoker distribution is. Like, what is the distribution of the smoker versus non-smoker in my data set. So for that, again, I'll use count plot only. And again, for this, I'll put x equal to smoker, and my data equal to data set. And I'll do the same plt.title here, and I'll say it as smoker distribution. So let's see what we get here. So from this, we get to know that majority of the people in the data set don't smoke, which I think is a good thing. So, and fairly less amount of people who smoke. So similarly, we can do the same plot for a region to see what is the distribution of region that we have here in our data set. So I'm just going to change this to region here, and yeah, region distribution. So yeah, so my region is You can see Southeast carries like a more like the count of Southeast regions is more in our data set. So yeah, now we have had a look at our categorical features, like how are they distributed. Now just have a look at how what is the scenario for our numerical features. So in the numerical features, you can see we have age, BMI, the output variable, charges, and even children. So let's just I want to look at age first. So for this, we will do a distribution plot on Seaborn, which basically allows you to see the overall distribution of the data set. So we'll just run a SNS dot, it's called dist plot. And then I'm going to put data set of age here. And I'm going to put the color as green. And I'm going to put this factor called KDE equal to true. So KDE is nothing but it's a kernel density estimator. It basically draws, like if you have a graph, it basically gets the overall PDF, the probability distribution function for the overall graph. So it's a good parameter that gives you a good picture of the graph. You can find it in the, you can just, as I did for the count plot, you can just Google up Seaborn dist plot documentation, and you'll be able to find what it does. So yeah, so you can look at age here, and probably we see that the age distribution, what I know from here, the people from the age 18 to, I would say, 21 have a lot of distribution given in this data set. And like probably I would like to explore what is this age distribution, like for factors like is what is the distribution of smoker for this age? Like are there other people in this age who are smoking? And what is the distribution of, like, what is the charges that people in this group are incurring for insurance? So probably we'll do that in the later stages. First, let's just now have a look at the distribution of say BMI. So we'll do the same thing here. SNS dot displot. I'll just copy this up here, and then I'll just make this to BMI, and I'll put the color same as it is. And yeah, let's just have a look. So yeah, for BMI, we get a perfectly normal distribution, a very good looking curve. So we can see the average BMI is 30. I don't know what it is, what the BMI definition is for normal people. Probably I would also like to explore this feature also. So for BMI people with BMI greater than or less than this mean value, what are the charges for them? Probably try to explore that question as well. And let's just have a look at our target feature now. And let's just see how is my charges distributed. So yes, let's so for charges, you can see it's mostly a skewed graph, skewed to the right, where a majority of RPF, the density you can see is around this region. So like for some people incur most of the charges for basic insurance, whereas these are some outliers that you see which can occur for emergency situations where you have to pay more insurance. So yeah, like now that we have investigated almost each feature, we'll try to answer some questions that we feel would be good to take up for this analysis. So like as I said, I wanted to look at age. So from age, what we got here was majority of the people are in this age group for our data. So I want to like sort of check maybe for to start things, for which age group is my insurance price the maximum. So yeah, this is kind of similar to what we do in SQL, but let me just try to do it here. So I'll just put this as X equal to dataset dot. I'm going to do a group by here, and probably group by, since I want to group by over age, and the metric that I want to calculate while grouping by is called charges. And this will just sort of create my aggregated age over charges, and I want to get the maximum of it, right? So let's see what this gives us. Data frame object has no attribute. Oh, so I again forgot to put group by here. So yeah, this should work now. So I'll just output this and let's see what we getting here. So yeah, this is sort of giving us the maximum value, but what I want is for which age the insurance charge is maximum. So I don't think I know how to do this. So like there's absolutely no problem. I can just sort of Google this up on my browser. So let's see what I want. I want a value based on another value, right? So let me just try to check the internet if I can find how to find a column, how to find a, yeah, I think I have this here. So how to find a column value based on another column value in Pandas. So like always, like you should look at Stack Overflow solutions, like they are very good. And like I've almost been able to find solutions to my problems whenever I'm browsing through Stack Overflow. So let's just look what it has. So I will just jump right here. So what are they doing here? So you can use a loc, and then, okay, so this tells what is the value that you want corresponding to this value of A. So here what I'll do, I'll put my charges here. So df of charges equal to df of charges dot max. And for this maximum charge, what is my age? So comma age. So yeah, I think that sort of solves the problem for us. So yeah, let's just try doing what we just saw. So I'm going to do dataset dot loc bracket dataset. As I said, like we'll just put charges, and we'll put the charges value to max. And we'll do a dot max, and then comma, as we saw in the Stack Overflow solution, age. So I think this looks good to me. Oh, okay. Oops, I forgot the quotes for age. And let's see what this gives us. So yeah, so now we figured out, like for age 54, our charge is maximum. So yeah, this was like how you maybe when you run out of, you want to answer something and you cannot find it, probably like you can just Google it up and see how that works. So yeah, now that one more question I would like to check, as I said in the beginning, that since our majority of the age distribution is between, you can see there's a peak for 18 to I would say 21 or 22. So I want to answer some questions. I want to, for this age group. So like I want to check if for since the majority of ages come under 20, is there any relation between the smoker and age for this age group? So I'm just trying to see whether what is the distance, like what is do people between the age of 18 to 21 smoke? So yeah, let's see what we get here. So for this, we'll use a library from Seaborn called catplot. It allows you to do all sorts of manipulations with categorical features. So yeah, you can find more details about this library in the Seaborn documentation. That is where I learned it from. So yeah, let's just put my X feature as smoker, and I'll put my kind equal to count here. And then I'll put this hui parameter equal to sex. And then I'll also have a palette, or maybe we can skip that. And then I'll put my data equal to, so since now I want my data only to be of the age 18, right? I want to explore that area where my data set is between 18 to 21 range. So I would just like to look at the results where the age is 18. So I'll probably subset my data set here, and let's see how it what we do here. So here I'll put data set of data set dot age equal to 18, right? So let's see what this gives us. Yeah, so now we have our plot here. So this, what does it say? So for the people who don't smoke, the count is high for the people in the range at the age 18. But for the people who smoke, there is also a less count, which is a good thing again. So now we got to know about the smoker and age relationship for the age 18. So now I want to further delve into this question where I want to see what is the charges distribution for this particular graph. So what I mean is, do people in this age who smoke, do they pay more charges or do they pay less charges? And people who don't smoke, do they pay less charges or do they pay more charges? So we are just going to do that by using a bar plot here. So SNS dot bar plot. Again, I'll put x equal to sex, y equal to just a second here, mistake. So my y equal to charges, and then I'll set my hui parameter to smoker, and then my again I'll just copy this away because I'm exploring for this age only. So data equal to data set of age 18. So there is some problem in data set equal to data set dot age equal to 18. So I missed the quotes here for smoker. So yeah, this should work. So yeah, this hui parameter is just basically it creates this one more filter here. So it gets you the smoker as well, along with the two parameters that are already there, sex and charges. So you can see here for the people who sort of smoke, so uh, they are also paying even at the age of 18. Smoker spend much more on treatment than non-smokers. So yeah, this is a sort of a expected uh, uh, assumption that I had. I just wanted to check that up. So yes, so now I would like to maybe like just check something for region now. So which region has the highest which region bears the highest charges? So for that, I'm going to do dataset dot group by, and then I'm going to group by region here. I'm sorry, region. And then I'm going to get the charges. And then I'm going to get the max. And then I also want to sort the values so that I can see which region had the maximum charges or values. So yeah, let's see. I would just want to output y. So yeah, you can see Southeast is the region that had the maximum charge. So yeah, like that was also one conclusion that we got. Now I want to check the, maybe I can visualize this in a better way because it's not clear to me. So I'll just use a bar plot here. So SNS dot bar plot x equal to region, and then my y equal to charges, and then this time I'll put the data as data set because we are done looking at the ages 16. So let's see what we get here. So you can, as you can see from this graph also, it is clear that people in who are in Southeast, they are paying much more. Their insurance charges are quite high compared to other region. So as I said, I wanted to explore this factor called BMI as well. So for that, since I don't have much clarity over BMI, I would like first, let's just check what the average BMI is. So BMI values. So yeah, it says if your BMI is less than, you fall in the underweight range. Okay. So if your BMI is 30 or higher, it falls within the obesity range. Okay. So yeah, this is one thing that I want to target. I want to see whether people who have a BMI greater than 30, are they paying more insurance? So yeah, let's just get back my coding palette again. Yeah. So what I will do is I will just put so I want to get the charges. I want to check if for BMI, for people who are obese, do they pay more insurance charges or not? So I can again visualize this using a disk plot. and we will see how does that come out. Data set of, I would say, again, I want my I want to subset my data set for all the values for which the BMI is greater than 30. So yeah, this is what I'll do here. So yeah, data set dot BMI greater than equal to 30. And for this, I will get my charges. So yeah, and I'll put the color here as just say yellow. Yeah, so this looks good. I'm getting a distribution plot for charges. Like I want to check whether people in this, what are the charges that people who are obese is the distribution of charges high or is it less? So let's see. So yeah, you can see probably like the distribution of charges is quite high for people whose BMI is greater than 30. So yeah, like this also gives us a good estimate of like people who are obese, maybe they are running into some diseases for which they have to pay extra cost of insurance. So yeah, I would now my main thing is I would like to compare it with people who do not whose BMI is less than 30, meaning those who are not obese. So let's get into it again. I just changed the BMI to less than 30 and let's see what we get here. So yeah, as you can see, the graph has shrunk a bit. So you can clearly see from the values here that people who have BMI less than 30 pay less insurance because they are not obese. So yeah, that was for this question. Uh, so like what, well, now we have almost checked BMI. I want to also look at what is the like charges when it is, for age group, like people who, like what is the charges distribution, like people, if somebody's 18, is he paying more charge, or if somebody is 30, is he paying more charge? So how does the insurance charges vary with age? So for that, I'm going to use a bar plot again. So sns.bar plot x equal to age and y equal to charges, and my data equal to data set. So what is the problem here? sns.bar plot x equal to age. Okay. Oh, so I didn't put the percent here. So yeah, this graph is not clear to me. I think going with a bar plot is not advisable. So I think we'll go with something called LM plot, which Seaborn provides. It's basically a linear model plot. So it'll sort of plot a linear graph as you do in regression. So it'll just draw a straight line to see how does charges vary with age. And we are also going to just to add more granularity to this question. We are just going to check if people with the age group, how much charges are they paying with respect to if they are smokers or not. So let's do a LM plot here. LM plot, yes. So x equal to age, y equal to charges, and I'll set my hui parameter to smoker, and my data will be equal to data set, and I'll put the height of my figure to 7 so that it appears it fits this palette. So x equal to age, I forgot this, my bad. So I think for charges. So yes, let's see. So as you can see, we have got two line plots for one, which is people who are smokers, and for who are non-smokers. So as you can see, yeah, as your age is increasing, and if you're not a smoker, the charges increase. But if you're a smoker, the increase is way higher. So people who smoke, for them, the charges increases with age. So yeah, this was also an interesting question that we try to solve. So yeah, I think this was it for the exploratory analysis part of this segment. So now, like, this is what I mean. Like, this allows you to get more understanding of the data. You can tell your stakeholders, okay, this is what I found from a data set. These are the conclusions. So it creates a very good impression that, okay, you have understood the data set and now you are ready to, sort of go to the modeling stage of your problem.